Swayam Prabha. Digital India. Educated India.
Okay, let's start. See, today's lecture is primarily to cover the Indian Concrete Institute Handbook, which gives the gamut of precast concrete for buildings only. And this coverage will give you a wide base of this application of precast concrete. Now, before I jump into the handbook, I will talk about some positive stories in India. Yesterday, when Professor Radhakrishnan started, he started with a very negative picture, very depressing. But I will give you positive pictures. And also, I will tell you about some pioneers in the industry. I do this almost every my course which are related with application. This I felt that when I became a teacher here, one of my senior colleagues, Professor K.N. Satyanarayana, used to teach a course for the first year freshies, the BTechs who are joining. It is called Introduction to Civil Engineering. And he used to ask a question, name a famous civil engineer, just like in a quiz. And you know what? They used to write Professor K.N. Satyanarayana. That means the pathetic state is that in our country, we are not knowing about the pioneers in the field, in the profession I'm going into. I know so much about the celebrities, but none in my profession. It's a very sorry state. Also, we are very much lacking, especially I'm telling this to the teachers. Don't think that you are in ivory towers. They are not towers, they are not made of ivory, wherever you are. You have to stay connected with the industry. And hence, today what I'm showing and the lecture tomorrow will cover the industry aspects, okay, which are there in India. Every single photograph is from India, except one or two, okay. Try to go for field visits, make the students aware, make them excited of civil engineering. Yesterday, I was in the Board of Studies meeting of Bagalkot Vasaveswara Engineering College, Karnataka. Half of the civil engineering students are failing. I said, why? Because the students are not interested. They compare themselves with the high-paying professionals. Then who will change this? Will the doctors help us? Will the lawyers help us? No. We have to help ourselves. And I believe the primary beneficiaries of this course, the teachers, have a responsibility to excite the students and also the industry people, that we have to elevate our image of our profession. Okay, Introduction to Precast Concrete Buildings with reference to ICI Handbook. See, the precast concrete was there in our country even before independence. Okay, but they were in a small scale. The large scale happened with the establishment of this big organization called Hindustan Prefab Limited. Can you please identify a few of them who are in the photographs? Prime Minister Jawaharlal Nehru. On the left side is Indira Gandhi. On his right side is Amrit Kaur. Okay, and few other dignitaries. Now, this Hindustan Prefab Limited, the way they started was they mostly went for components, not for residential houses, but mostly for industrial components. Now, this picture I got from one person who migrated to US. He is with University of California. And he used to work in a company called Heavy Electricals Limited. Okay. And here you see the industrial buildings in this factory of Hindustan Cables, that what they're using is they're having this precast segmental post-tension girders. And please note, these are built in 1960s. Okay, 60 years, more than 60 years back. Okay. And over these girders, they're providing purlins. And over the purlins, they're providing the roofing elements. See, when we teach civil engineering, I'm saying especially structural design, we need to understand the load path. Where does the load primarily come from? For a gravity load design, it starts from the roof. Then how the load gets transferred, that means from the roof to the purlins, to the trusses, then to the columns. And in fact, in your tutorial, this will be the question. Now, this is another example from Heavy Engineering Corporation Limited in Ranchi. These are scanned photographs from the newspaper. These are for the residential houses. Okay. And you can see the frame type of construction. The frame type of construction means that we are having beams, columns. These are the skeleton of the building. The Structural Engineering Research Center, which is in an adjacent campus to IIT Madras, they also pioneered the precast concrete for economically weaker section people. Okay. They have a mandate that to make technology which is affordable for mass housing. And these houses were near for the fishing community, near the beach. Yes, it is not everything was success, because at that time there were some leakage problem. And what happens in the fishing communities, they use a lot of water and they will wash everything, and that aggravated the deterioration of the leak proofness. Now, over the years, different sorts of chemicals and other types of caulking materials have been developed. The same thing, if it is done today, it will be done in a better way. Okay. In the bottom right, you can see some precast roof structures. SERC used to conduct courses on precast concrete way back in the 70s. Don't think that we are conducting this for the first time. There was Dr. Parameshwaran, who used to champion these courses in SERC. Coming to the Indian pioneers, let me start with Baburao G. Shirke, who had established this company BJ Shirke and Group, from where you will be having the speaker of the last day, Yogesh Kajale, one of the leading designers currently. Now, Baburao Shirke brought the technology of, it's called Ciporex, and used in mass housing. And BG Shirke has done pioneering work, not only in Mumbai, Pune, but in Gurgaon, in Chennai. Okay, I will be talking about that tomorrow's, that what did the Shirke Group did in Chennai. Shirish Patel, he established the firm Shirish Patel and Associates, where we had pioneering engineers like V.V. Nori. And this particular building, the Petite Hall, see the year 1973. And this building still stands in a coastal city of Mumbai. That means precast concrete can be durable, at least we are saying 50 years of lifetime. After that, what happens is the functionality changes, the taste of the people changes, the society changes, and we don't expect buildings to be usable after 50 years. But at least for 50 years, we should guarantee that the precast building should be there without much of durability issues. Yesterday, Mr. Raghavan had mentioned about Dr. A. Ramakrishna. I was fortunate to have personal contact with him during writing of this handbook, which he had championed. Dr. A. Ramakrishna's son, Professor Meher Prasad, is my senior colleague and a mentor. Okay. Now, whatever you see in Larsen and Toubro today, where because of a few pioneers, apart from Mr. Larsen and Mr. Toubro. And one of the Indian pioneers is Dr. Ramakrishna. And he had a single job throughout his life. What was that? L&T. And They started from scratch and went on to make it the largest construction company in our country, which can compete with the other international firms. That's why what I'm saying, those who are working with L&T, I would say you are blessed to work in such a large firm, but try to have the spirit of giving back. Okay, don't compare your salary with some, IT or data science type of jobs. No, you cannot compare. If today farmers say that I'm not getting salary, I will stop my job, who will feed us? That's why in our society we have to accept that we will be having different salaries. It cannot be uniform. The world is not a socialist platform. Okay, and hence let's be passionate with whatever we are doing. Now this particular building, I would say if you get a chance, at least those who are in Chennai should visit the Larsen & Toubro campus and try to appreciate these magnificent buildings. This is built on a single, like a core from which there are cantilever arms. Parts of it are precast, but yeah, most of the core, these are all cast in place. Mr. Sundaram is an architect, but he has pioneered precast construction. This stadium in Bengaluru, the Kantirava Indoor Stadium, has used extensive precast elements. The roofing, okay, the seating inside, and we will be talking some of this in tomorrow's lecture, where I will be talking about different components from the structural design point of view. He was also the president of this Structural Engineers World Congress, which is a premier organization. Now coming back to today's topic, the Handbook on Precast Concrete for Buildings. This was an initiative of the Indian Concrete Institute, which was championed by Dr. A. Ramakrishna, and we got the help from our neighboring institution, College of Engineering Guindy, then Structural Engineering Research Center, and most of the material comes from the Larsen & Toubro projects. Now, this covers a wide-ranging topics related with precast construction. Okay, it has been written in a simple and easy to read. We were told that it should not be an academic thesis. It should be a document which practicing people feel comfortable. And of course, there are references. You cannot say that I read this book and I know everything. That is the utter foolishness. There are references which are easily accessible, from which you should definitely learn of whichever particular aspect you are working on. So the target users are the engineers in public and private organizations, at least the beginners, it will help. The professionals in the construction industry, the material suppliers, okay, the contractors. Now the decision-making officials. See, tomorrow I will be talking about this initiative of Global Housing Technology Challenge, which has been taken by the Ministry of Housing and Urban Affairs. Now these ministries are not run by civil engineers. These ministries are run by IAS officers. And they have to be also made aware of what are the possibilities with precast concrete. That means as an engineer, as an academician, you should have the communication skills to convey persons who are not in your profession, but who are actually taking the decision and giving the the finance, that how to convince that this can work. And of course, this we also target the educators and students. The chapters are, the first chapter is on buildings and urban infrastructure related with buildings. We are not talking of bridges here. That's another big ball game. I did not mention the name of yesterday. It was said Engineer Sridharan. Okay, because they are more in the bridges. That's why I did not mention their name. I mentioned the names who are related with buildings. Okay, and Alim Chandani also was mentioned yesterday. I skipped his name. Okay. The urban infrastructure, what we mean is that in a building project, even in the accessories around the building can have precast elements. Okay, that is meant by the urban infrastructure. Next is the precast concrete building systems and overview. This is the structural design point of view. I will discuss this particular chapter tomorrow in more details. Then the foundation and underground structures, the structure analysis and design. Now here, it is not meant for learning structure analysis. It is to see what are the essential differences in the analysis of a precast concrete building vis-a-vis a cast-in-place building. Then pre-stressed precast concrete as applicable to precast members. Seismic design of precast structures. Here also it does not teach seismic design from the basics. No, there are books for that. But here, what are the, how you can analyze a precast concrete building, that's what it is mentioned. The material properties are written in two chapters. One is the properties of the material, and another is the products. Let me tell you, even as academicians, you may think that no, I don't want to meddle outside my classroom. No, please read company catalogs, okay, to understand what are the type of products the industry is offering, okay, and make them aware in your class. And precast industry, as it has been saying, that it's an industrialized system, and we have to make our students aware of this. Joints and connections, a very important chapter. We are calling Professor Jaya tomorrow to speak on this. I will be skipping the details of this. Production, handling and erection, Professor Liberato will be talking about this. Quality control and assurance, what are the specifics for precast concrete? I will be mentioning that. Contracts and taxation. Mr. Raghavan has mentioned there are specialties in it. I will be just briefly mentioning this. Although we are not, in this course, we are not covering them in details. Information technology, that how we can use the IT in precast construction. Maybe artificial intelligence will also come, but right now that book doesn't cover this book. And finally, there are two case studies where they have shown how the analysis was done briefly, how the construction, what type of elements were selected. These are mentioned in these two case studies. Now, the authors of the first was written by Dr. A. Ramakrishna and Dr. Sivarama Sarma, both from L&T. The second one was written by me, which I will be discussing tomorrow. The third one was written by Professor S.R. Gandhi, who retired as the director of National Institute of Technology in Surat, and my colleague, Professor Suvati Banerjee. The fourth was written by Dr. Ramanjanelu, who was with Structural Engineering Research Center. The fifth one, you met him yesterday, Mr. Raghavan. The sixth one, Professor K.P. Jaya, you will be meeting her tomorrow, and Professor Meher Prasad, my senior colleague whom I mentioned. The seventh chapter were written by Dr. Ramachandra, Dr. Manamohan Kalgal. They are from Ultratech Cement, and Mr. M.N. Ramesh from Safcor, Raj Pillai from Star Wars, and Dr. Sivarama Sarma. I mean, because this materials chapter is a, Radhakrishna will be covering some of this. And the joints and connection was written by Professor Jaya. We are fortunate that she will be coming. The ninth chapter on handling was written by Mr. Mohan Kumar from Rani Precast. Unfortunately, he is not with us. Dr. Srinivasan from SERC wrote the chapter on quality control. Mr. Raghavan wrote the chapter on contracts and taxation. Mr. L. Chandrasekhar wrote the chapter on the information technology. And Mr. Saladitya Shaha from Larsen & Toubro wrote the case studies. That means whatever I'm presenting today is essentially their contribution. The first chapter. Now, some of these have been mentioned earlier. The way the precast concrete has been promoted in this handbook is based on the three main categories which are talked in construction management. The first one is quality. Okay, that we can have factory-made products which can be produced even in inclement weathers, efficient quality management, accuracy in dimensions, possibility of textured finish, which I will be talking tomorrow, what is meant by that, and the durability aspects. Next, the time. which is we are talking of mass housing for our masses, and time is the premium. Okay, and the precast is one of the options. Okay, please note, I am not saying that this is the only option. No way. There are other options also. Okay, which the government is promoting. In precast, we have the rapid construction, provided we do the planning. See, there are certain prerequisites for the success of precast. Okay. Use of mechanized ways, of course, that means you have to purchase this extrusions and battery molds. Suitable if it is modular and repetitive. One in building, it's no point. I mean, no investor will be interested in that. And there can be parallel activities going on. That means when the foundation is being made, typically the foundations are made of cast in place. At that time, the superstructure elements can be produced in the factory. Coming to the cost, obviously we have to talk about cost whenever we are talking of mass housing. This leads to, I mean, why precast can be beneficial in cost? Because we are using optimum use of materials, limited temporary supporting structures, multiple formworks, and availability of standard shapes. Now, this is yet to come in our country. You cannot just go to a precast producer and say that I want to purchase this section. That type of cataloging or system hasn't come yet, unlike what happens in the departments of transportation in US. And we expect reduced maintenance unless there are durability issues, I mean, under leakage issues, and there can be early return in investment for the real estate developers. Now, this photograph, I had the opportunity to visit this site, the IIIT, Indian Institute of Information Technology in Sri City, Andhra Pradesh. The superstructure was built it is a 5-storied building for the hostel. It was built in 2 weeks. And it was an eye-opener for me that how construction can be done in a mechanized way. Okay. Now, what are the miscellaneous advantages? Today we are talking of greener buildings. Now, my friend and my colleague, Dr. Sivakumar, he works on this computation aspects of what is called green. And he can tell about that how we can qualify this statement that precast is a greener solution than conventional cast in place. Plastering can be avoided. In our country, we spend a lot of manual effort in plastering. Okay. Additional features can be incorporated under special type of buildings, thermal and acoustic control, reduced manual labor. If you had noted the photograph of Professor Liberato yesterday, in that factory, only one person was standing. The whole concept in West is a bit different. In our country, of course, we cannot afford that. We need to provide employment, but still, things should be done in an efficient way. Better safety and environmental conditions, and suitable for laboratory testing. This is in our lab. We tested what is called biaxial voided. The proprietary name was biax type of slabs, where they introduce spheres, plastic spheres, to reduce the weight. I'll be talking about it tomorrow. Now, what are the challenges? Is everything look positive? No. First is the initial high cost of setting up factories. We are talking of an industry. Okay. And hence initial investment is necessary. Teamage, who financed it? It's the Chennai Silks. Those type of companies have to come up to help us. Okay. High transportation costs for delivery of precast components. Given our road conditions, this is a challenge. And unless we have precast factories throughout the nation, you cannot say that I will transport. Even when our building, whichever you will be seeing, the sports complex, which was built by Teamage, getting the products from, I think, Coimbatore, the Tirupur factory, was a challenge. And of course, now they have established a factory in Kanchipuram to meet the Chennai requirements. The erection of the components need special type of these cranes and excise duty. Mr. Raghavan mentioned that in our country we have a special clause which inhibits the precast manufacturers. I'll be briefly talking about that today. And need modular design with repeatability. That means even the architects have to be familiar how to design for using precast concrete. They cannot come up with something and then the structural designer is to figure out how to make it precast. No, it has to be, yesterday Mr. Raghavan rightly said, it has to be an integrated approach. Okay. Skilled workforce. Now, crane operator, you cannot just put someone to do it. No, we're talking of high risk type of activities. And hence, as in aviation sector, they're having a crisis now. Similarly, in our construction industry also we have a crisis. Safety mock drill. Now, this is important. Companies like Larsen & Toubro does it, but the smaller players, they have to invest in that. Coming to the second chapter, I'm just briefly touching upon that in this chapter, we are talking primarily of two types of precast systems. The one is a wall type, where you make wall panels, maybe with window openings. And you see that this particular plan, the way the architect has conceived, he or she had kept in mind this repeatability or the modular. Now that is necessary, and this is coming from a very famous company, the Starworth Infrastructure and Construction Limited. I talked about Mr. Raj Pillai, who is involved with this. Okay, the other type is the frame construction. Now each one has their benefits and domain of usability. I will be talking that tomorrow. In the frame construction, you are having beams and columns, and accordingly your building plan is also different. However, you can also have a mixed type. That means within a frame type building, you can have panel type elements. The foundation and underground structures. Now, in the foundation, we have additional advantages of precast concrete. First, that we can backfill the soil very fast. In our country, what happens is we have this monsoon season in many parts of our country. At that time, construction is invariably affected. And using precast is a solution that if you can still continuously do the construction. Curing is not required on the site, and it is also suitable for fluctuating groundwater table. In a city like coastal city like Chennai, where our groundwater highly fluctuates. Come December, it is almost at the ground level after the rains. And come, say, April or May, it is substantially below. Now, these are the challenges in the construction of foundations. Okay. You can ensure high grade and quality of the concrete. For the pile construction, the bentonite slurry can be an issue regarding disposal, contamination of the concrete. That can be avoided if I am using precast piles. And no necking or the bulging of the piles, which can happen if I am using conventional cast in place piles. This particular photograph is from Precast India Infrastructure Private Limited, Pune based, and Kapilesh Bhate, a very good friend of mine, will be coming in the last day to speak about his company. On the photograph on the left, this I had taken when I visited the factory in Tirupur, Timage, that these are the way we teach foundations is shallow foundations and then deep foundations. Similarly, here also in this chapter, that's the way it is written. But the first is the shallow foundation, which are for columns, pat foundations, or it can be for even walls like boundary walls. And the other group is the deep foundations. Now, this type of pile foundations are very common in the marine construction. The photograph on the left is from a Malaysian company in the Berhad. They have promoted this throughout the South Asian region. Even they are having an office in Chennai. They made presentation to our students. Now here you can see in this photograph is taken from the Chittagong in Bangladesh, that these are very high quality type of members. These shoes at the bottom are for the splicing the piles. On the right side, you can see Larsen and Toubro also has done this precast piles. Most of these are what is called pre-tensioned and spun. What is meant by that? Pre-tensioning, Mr. Liberato will be covering. Spun means, it means when you have, it's a type of like in a mold, hemispherical mold, you are putting the concrete, then you're putting the cover to make a complete circle, and they're spinning it very fast. And that spinning does the compaction. And hence, it is not like a vibrator and you try to compact it. And this compaction provides much denser concrete. That's why these are called pre-tensioned spun piles. And similar technology is also used for the electric poles, masts, which you will be seeing outside. Apart from foundations, there can be miscellaneous other geostructures. Now, this is the left photograph is an international photograph. This is an intake well. And on the right side, again, it's Mr. Raghavan had shown. Now, this has been extensively used in our country, the fascia blocks for reinforced earth retaining walls. Okay, mostly for grade separators, and you just go outside our campus, you will see that. On the left, we see the reinforced earth wall of the Kanakadurga temple in Vijayawada. Our retired faculty, Professor K. Rajagopal, was highly involved with this. I had got an opportunity to work with him while testing these fascia blocks, that how you can use the geogrid anchors for these fascia blocks. Okay. On the right side, yesterday, Professor Liberato talked about these tunnel liners, and here you can see this. This is the inside of the tunnel that is being that has been made in Chennai and similar other places. Now we went to see the factory which is producing this. This is pretty high-end factory. We took our students there. The production is done by Larsen and Toubro, and you can see it's like a huge factory with assembly line type of processing. On the left side is an overall view. On the right side, you can see the molds. Now, each of this can be a seminar by itself. Now, I'm not specialist in this. This is again a very specialized area. Okay, that how do you analyze the tunnel liners, and then how do you design for it? Coming to the structure analysis and design. Now, whenever we do a building analysis using a computer, we have to be aware that we have to use appropriate finite element modeling. Otherwise, junk input will give junk output. First, the selection of the elements. Frame elements for the beams and columns. Here, we are not teaching finite element method. It's just raising an awareness. Okay. Membrane or shell elements for the wall panels, plate elements for the slabs, and the strut elements for infill walls to measure their axial compression resistance. Then the main challenge comes in the connections. See, when we teach reinforced concrete, in the first class we say, what is a frame? Frame consists of beams and columns which are rigidly connected. What is meant by rigidly connected? That the angle between the beams and the frames at the junction will stay 90 degrees even if under there is load, whether it is gravity or whether it is lateral. That's the way we start frames. But my friends, in precast, this basic notion may not be there. And hence, that should be taken care of in the analysis. Otherwise, things can go wrong. Now, there are two types of joints and connections. Now, this particular words, joints and connections, is a bit confusing. The way I view it is, traditionally in reinforced concrete, we talked about joints, beam to column joints, okay, slab to beam joints, which are the overall junction region. But now we are moving more towards the structural steel type of applications. The structural steel, they use the word connections, beam to column connections. And hence, the way I view it is the overall junction we can say as joints, but the detailing is actually connections, because we are trying to mimic the way they do it in structural steel. Now, there can be two broad type of classifications of this. You can use the words either joints or connections. First is the emulative. What is meant by emulative? That we are trying to mimic what we get in cast in place, that the beam column junction should be rigid, means the angle should be 90 degree. However, if you are not able to guarantee that, then the other extreme is consider them to be pinned. Okay. Or if I have a wall-to-wall connection, I cannot guarantee a rigid joint, just consider them a gap. In between, there is something which is called semi-rigid. Our steel fraternity has gone ahead in quantifying semi-rigid connections, and I believe in our precast fraternity also in future we shall see characterization of the joint behavior. That means what is the moment versus rotation. Now I'm not saying that it is 90 degree anymore. It can change from 90 degree depending upon what type of detailing you adopt. Now that's a long wait and it may come up in the future course. The other is the mechanical joints, or it is sometimes it's called jointed connections, which is like structural steel. That there most of the time we consider them to be flexible, like pinned, just a seated connection. There can be, of course, a semi-rigid connection. The way we do it in steel, similarly, we can have what is called semi-rigid type of connections in precast concrete. Now, let's try to understand the difference in the behavior of a cast-in-place conventional versus a precast with pin connection. So on the left, if I have the gravity load and we are assuming rigid joints, how does the resistance come? Where are our BTech friends? Today BTech friends are not there, they were sitting yesterday here. Okay, no, do not go back, you should come front. Okay, today this is empty. Okay, tell me, how does the frame resist the load? Primary load is the gravity load, which is there every second. Okay, since you're sitting back, I will not ask it. The beam tries to bend. Okay, while it's trying to bend, due to the rigidity of the joint, it also tells to the column, hey, help me. And then the column also starts flexing. And like that, the load gets transferred gradually to the foundation. And if you look into the bending moment diagram, we have the beam is trying to bend. If it is simply supported, it will just bend with positive bending. Gravity load is always downwards. But due to the rigidity of the connection, we tend to have what is called hogging moment coming up in the near the beam column joints, and that due to joint equilibrium gets transferred to the columns. And this is the bending moment diagram. I will ask you this diagram tomorrow in the tutorial. Please note it. Okay, you have to draw for a typical case. On the right hand side, let's see that these are like beams, precast beams sitting on corbels. Now this I am considering to be pin joint, although you can develop some semi-rigidity, but let's not consider that. If it is pin jointed, then the beam is having only sagging moment, okay, no hogging moment. But then since the corbels offer an eccentric loading on the column, there will be some moment coming in the column. Okay, it is not like a pinned truss that no moment is coming to the column. No, because there's a corbel there. The same construction, if I now look under lateral loads, in lateral load, what happens is that for a cast-in-place construction, we tend to have an inflection point somewhere near the middle of a member. Okay, that based on the inflection point, one side of a beam will be sagging, other side of the beam will be hogging. And In the columns also, at least in the upper stories, the inflection points are more or less in the center. And there also there is change in curvature where tension is on one side in the top and the tension will be on the other side in the bottom. And if I look into the precast construction, which Professor Liberato was talking yesterday, we have to ensure fixity at the bottom of the columns, which may be difficult under high gravity loads, high lateral loads. Now the columns have to be like vertical cantilevers because we are not getting the rigidity from the frame. And hence, now you see the bending moments in the columns. This is quite different from what we see in cast in place construction. And the beams are essentially free of moment under lateral loads alone. Coming to the types of structure analysis, depending upon the level of sophistication, we can classify this that most of the time our practicing engineers will be adopting linear. Okay, linear means it is a material linearity we are talking about. Stress is proportional to strain. Okay, and for earthquake we adopt a static analysis, which our code 1893 specifies. I will be discussing 1893 in the next week. And there is another option, dynamic, which is recommended for certain types of buildings where we should use the dynamic properties like mode shapes, which comes under the response spectrum analysis, or we can also solve the set of differential equations, which is the method is called the linear time history analysis. On the contrary, a company like Larsen and Toubro can have a cell where there are specialized persons, maybe with PhDs, who will be doing some advanced analysis to make sure that we get some economical result. Advanced analysis is justified only if you tend to get economical results. And there we take advantage of the nonlinear behavior of the materials. The static analysis is called the pushover analysis, which has become very common after the introduction of this method in the SAP, which has, in fact, Mr. Ashraf Habibullah, who is the CEO of Computers and Structures Incorporated, visited our campus way back in the early 2000s when he was promoting the use of SAP throughout the country. Okay, and the dynamic equivalent of the time history is called the nonlinear time history analysis. Now, people are doing these days different sorts of what is called damage evaluation, okay, vulnerability assessment using this. Mostly it is in the academic circle. On the right side, you can see that this project came to our IIT, that this is the multi-story buildings which came up in Bhoiwara in Mumbai for the slum. It was done by the Brihat Mumbai Slum Clearance Board. And this is the model of that. Now, it takes a lot of patience to develop this model and proper skill. Otherwise, you can goof up. Coming to the pre-stressed applications of precast concrete. Why do we go for pre-stressing? This is more or less, these advantages are same as cast in place, that we can get high span to depth ratios. Larger spans means it gives increased column free spaces, okay, which is a requirement for auditoriums. We did one project for IIT Palakkad, and in their auditorium they had to go for pre-stressed members. That was of course not precast, but without pre-stressing they could not have gone that high span. Otherwise, these beams will become very ugly and the self weight will increase. Reduced member sizes, once we are able to, this is the corollary, that we can go for a lighter weight because pre-stressing is counteracting the gravity loads. Less material consumption with precast, and once we are able to reduce the weight of the members, obviously for a large construction, we will be having a benefit in the seismic design, including the design of the foundations. Another benefit we get for pre-stressing is the durability. Apart from the structural design, the durability. That this is a very important, even more for bridges, that the uncracked sections can lead to much better durability, and it also increases the shear capacity and the stiffness if we are going for pre-stressing. Now, this is the type of factory we are expecting to see on Saturday. That this is from the image. This is of course in the Tirupur factory. That how they are producing this hollow core slabs. Okay, it's a assembly line process, which is a pre-tension bed. You anchor the strands in one side, stretch it from the other side, pour the concrete. I mean, you can see this long line, and this is the the anchored side. Okay, once you pour the concrete, then you have to extrude to give this voids, and this is the final product you see. Now, typically their properties will be given in the catalogs. Each company has their own, I mean, I would say standard, depending upon the type of machinery they're using. And this is another factory which I saw in Pune from the Precast India group, which Kapilesh will be talking about. And you can see what a mega scale precasting is going on. And please try to, in a field visit, try to observe the way these machines work. That these extruding machines have a different types of fixtures, and based on the fixtures, you can have different types of voids. Okay, depending upon the spans. Now, in our campus also, I would strongly suggest that please visit the ocean engineering. Maybe our teaching assistants, our students will help you. Maybe even our students also may not have seen this. In our ocean engineering, we have a wave basin which was built way back, I think in the late 70s or maybe early 80s. To have this long span, they went for this precasting of this folded plates. The diamond shapes are the stiffeners of the folded plates. They were cast on the ground, lifted up, and what I heard was that was a pioneering construction at that time. Okay. On the right side is an industrial factory. Tomorrow I will be talking more about this, the roofing of industrial sheds, which Dr. A. Ramakrishna had pioneered based on his German experience. These are pre-tension, that means the bottom chord is pre-tension, which is the tensile member. Okay, these trusses are being cast and lifted up. Over that there will be the purlins, and then there will be the roofing elements. Coming to the seismic design of precast structures. Now, this is an aspect which is definitely challenging. That whenever we go for a jointed system, we are inviting trouble. Now, there have been failure in India during the Bhuj earthquake. The school buildings, because the seating was not proper. Some of this, luckily, it was at 26th January. The children were not there inside. That's why in this school buildings there were no casualties. Otherwise, it could have been dangerous. But it's not only India. If you look into the Koyseri earthquake in Turkey, lots of damage in precast buildings. This is one thing where our designers have to come up with innovative solutions. Why are the failures? Because of the inadequate detailing. Primarily, it is the detailing. Okay. Inadequate sitting and diaphragm action. Now, I will be talking about this tomorrow again, the diaphragm action. Inadequate deformation compatibility between the different components. Okay, some are more flexible, some are rigid. Okay. Inadequate separation of non-structural elements. Now, these are written in qualitative statements, but these are very difficult to actually design. Now, what are the approaches of seismic design? Now, this is the one which has been there in our code for cast-in-place building, capacity-based design. Now, what is meant by capacity-based design? It is an intent. See, in earthquake design, I'm just primarily saying for my undergraduate friends, that we cannot afford to design to stay elastic. It will be damaged. Okay, there will be yielding. Okay, but the yielding should be sequential. Means we would prefer the yielding in the beams first before it happens in the column, and the foundation is the last line of defense for us. Members to yield at selected locations sequentially before damage of the connections. That means we want to save the connections. Let the yielding happen in the beam near the joints. That is the philosophy which we adopt in cast-in-place construction and in the emulative type of connections that we use in our precast. That means here the objective is to have stiff and strong connections. There should be ductility in the members. Okay, very important. And you have to accept that there will be damage which cannot be repaired. Now, on the contrary, there is another philosophy which is just the other way around. There he says, okay, wait. You are now saying that things cannot be repaired. Now, let me come up with a solution which can be repaired. How to do it? We are going for a design called resilient design. Okay, a joint to yield before the members. It's a control. It's like a fuse which you can change. Okay, that means these are deformable and ductile joints. Joints can be repaired, and the damage in the members is limited. That means hopefully they can be repaired. Now, this type of design is yet to come in our country, but we see, we hope it will come. Now, the behavior between, see, whenever you do the analysis, now we are focusing primarily on the seismic, and I had talked about this in the analysis chapter. We should be able to understand the behavior of an emulative connection versus a mechanical connection. In the emulative connection, there is transfer of moments from the beams to the columns and vice versa, and this is back and forth. Okay, you can see this is the typical type of connection that is adopted in our country, where you have cast in place concrete at the junction to ensure that we are indeed having emulative connection. That means indeed we are having rigid connection. Okay, that's why we need cast in place concrete around the junctions. On the contrary, if it is mechanical, then the transfer of moment is not like that. And then you have to understand, now it can be made semi-rigid by putting some sort of pins or angles. I believe Professor Jaya will be speaking more on that. Coming to walls, if the walls in the way it is connected in our country is that we tend to have some loops coming from the two adjacent walls, we place a rod and grout it. It appears emulative, but no, it's not emulative. They are going to crack. Okay, hence the designers typically consider them as gaps. Okay, that as if the two walls, stack of walls, are just carrying the load together. Sorry, not together, but just by side, individually they carry. Okay, even in this particular project, Larsen & Toubro had adopted these gap joints because we cannot ensure rigidity in that type of connection. A third type, which is coming up from the university side, and this is the innovation we are talking about, is called design which is based on energy dissipation and self-recentering. Now, what is meant by that? In earthquake, if you are able to, it's a matter of 40 seconds to 1 minute. If I'm able to sustain that without the collapse of the building, by that itself, we will be able to save lives. What happened in Bangkok or in Myanmar, it is an eye-opener that same can happen in any of our big cities. Now, this particular concept aims to reduce the drift and eliminate damage of the members. Here, there are joints which are made such that they open up and close with certain dissipating elements in between, which will help to sustain that vibration, avoids uncontrolled cracking, and there are inserts of mild steel across these joints. Also, there can be unbonded post-tensioning, which gives this self-centering effect. Let's try to understand this in a schematic sketch. That here, this is a beam column joint. In US, typically what happens is they don't like the corbels. They say that that's an extra part of the formwork which creates trouble. We will not have corbels. We will be supporting the members temporarily during erection. Then there will be this post-tensioning strand which will be going from end to end, and then they will stretch it and lock it. Okay. And in between, there is this red lines also are provided, that is mild steel, which is the energy dissipating component. The strands cannot yield. If the strand starts yielding, then you lose the self-centering capability. And this is the way it tries to behave, that it is like it is called a rocking joint. That means now you have deliberately kept the joint to open up and close. While it is open up, the mild steel rods are yielding, and hence they're dissipating energy. Okay. On the right side, this I got from Professor Stefano Pampanin, who was in New Zealand. Now he has moved back to Italy. That this type of energy dissipating, external energy dissipating elements can also be provided in this parking garage type of structures. Now, this is another, the concept is similar, but for the vertical direction, that we have vertical post-tensioning, where the post-tensioning will provide the self-centering aspect, and then there are mild steel connectors which will dissipate the energy under this rocking vibration. Now, this is an experiment Professor Sridharan from Iowa State University, I got this from him. He was very much involved in this. He also works with industry partners to develop this type of connections. And he was a student of Professor Nigel Priestley, and in University of California, San Diego, they did a lot of these tests under a program called PRESSS. You can Google this and see what information you can get. Coming to the diaphragms. Now, what is meant by a diaphragm? Yesterday, Professor Liberato had already mentioned this, that during an earthquake, the load is an inertial effect. It is the heaviest component of the building which generates this inertial effect, and the heaviest components are the slabs. Now, unless these slabs are able to mobilize the supporting vertical elements, then there can be a catastrophe. And that's what can happen in precast building. Hence, if the slab is jointed, that means now you are saying that, okay, the slab you are making using precast planks or hollow core slabs, they have to be connected to act like a monolithic. And also the connection to the supporting walls or columns have to be proper. Now, this diaphragm design is a topic by itself. In US, they have developed a method called DSDM. Okay, right now I'm not able to remember the full form, but this methodology has come up, which is a capacity-based design of the diaphragms. Now, in our country, we typically go for the left-hand side, where what we do is over the precast slabs, we put a structural topping with adequate reinforcement. What are the types of reinforcement? Again, I will be discussing this tomorrow. Okay, let me skip that. Whereas in US, what happens is, especially for parking structures, they will say, no, we will not involve another contractor for this cast in place concrete. That's an expenditure. We will go for like stitching type of connectors. Now, lot of experimental work has been done to characterize this stitching. Okay, and these are the shear connectors in between which are placed in between the precast panels. Now, this is a photograph I took when I visited the Sri City project, and I believe you will be seeing the same thing in our mock-up building, which is coming up just adjacent to this place. That they're putting first this precast hollow core slabs. They will be making grooves, and some bars which are sticking out from the supporting walls will be bent and placed inside the grooves. And then a concrete will be placed with reinforcement. The purpose of those bent bars are called stitching reinforcement. By that, we are trying to integrate the slabs with the supporting beams so that we have a monolithic action. I also believe that this is what should be done in our country, because the mechanical jointed type also needs attention in terms of durability. I feel in a city like Chennai, I would be more conservative in terms of the connections, and hence I prefer this, which is based on like an emulative type of connection with on-site concreting. On the right hand side, you can see this is a photograph I have taken from the handbook, and here you can see that these are the grooves where the bars from the supporting beams will be bent. Coming to the material properties, I had already talked about their the authors. See, the materials that are used are more or less, we know this in our undergraduate concrete technology course. Okay, cements, supplementary cementitious materials, aggregates, chemical admixtures, reinforcing bars, pre-stressing tendons. However, these days there is a multiple type of usage or type of design, and we have to be aware which one is suitable for what. We are going for this term called high performance concrete, then ultra high performance concrete, fiber reinforced concrete. This needs a substantial knowledge in concrete technology to address this type of variants. I mean, gone are those days, just 1:2:4, those type of concepts are not there, or at least should not be encouraged. In the precast industry, if you are industrializing the process, the requirement is to have high early strength so that you can release the molds. Very similar to what happens in a pre-tension member. Okay, whether you pre-tension or not, you need a high early strength. That means about 10 megapascal in 10 to 15 hours. We expect how durability, and there can be miscellaneous requirements based on the application. High flow mix, okay, so flowable concrete, or the contrary, the stiff mix, okay, all can be done. We can introduce color, texture, we can make it lightweight. There can be thermal, acoustic insulation, and fire endurance. That means different types of mixes are possible. On the right side, you see that how the concrete is being poured in wall type members in the Timage factory. Coming to the joints and connections, I had already mentioned that broadly we classify the joints into two types: emulative and mechanical, or it's sometimes they are called wet and dry. Now, in this chapter, what is highlighted is there can be numerous types of joints in precast construction, because we are deliberately going for a jointed system. For the slabs, slab to slab, slab to beam, slab to wall, slab to column, if it's like a flat slab type of construction. Each joint has to be taught, has to be learned. It's a huge task ahead of us, the educators, to make precast concrete a subject which has to be taught. Okay. Coming to the beam elements, beam to beam, beam to wall, beam to columns. Column elements, column to column, column to foundation or footing. Wall elements, wall to wall, wall to footing. Besides this, we also have facade elements, and we can have miscellaneous elements. Now you can see the classification of joints in terms of what are the members being connected. So many different types of this. Okay. This classification I had told before, the emulative connection, where we use on-site concreting to mimic the cast in place construction. On the other hand, these are the mechanical type of brackets which can be used. However, again, the durability is an aspect which we have to think of. Then the emulative connections, what are the characteristics? That it is mimicking cast in place based on concreting, expected to be corrosion resistant, provided the concreting on site is good. This is somewhere again we have loopholes. Quality control required at site, and behavior is expected, I have written within quotes, monolithic, provided it is designed properly. However, it requires inserts of reinforcing bars, dowel bars, and some connectors. We'll be talking about this tomorrow. On the contrary, the mechanical joints, they are mimicking the steel connections, which are mostly based on mechanical components, needs protection against seepage and corrosion. That means we have to have durable caulking material. Quality control in tolerance is required at the machine shop as well as the casting yard. Now, this is something, I mean, I cannot say that the tolerance aspect, a company person can talk about this, that what type of tolerance issues you're facing. Okay. The behavior can be anywhere between rigid, semi-rigid, flexible, or even we can have dissipative joints. Okay. And this also requires different sorts of inserts, and detailing this can be a task. Okay. If I look into some photographs, I have taken these photographs when I went to the Sri City. What they have adopted for this slab to wall connection is, it's like a serrated type of edge. Why? To increase the sitting area. And if you look into this, that here they are having a hole through which they will pass the dowel bars. We saw the operation, that means this wall elements are brought, placed here. You can see that the dowel bars are going through the holes, and similarly from the other side, another slab element will be placed, they will be grouted, and finally it will appear like this. This is the slab to wall connection that they have adopted. It's more like an emulative type of connection. Now, these are certain drawings which I picked up from the industry, that how they are going for it, that over these are the type of stitching they do. I will skip the details. You can, most of them is understood, that between the wall elements, because I'm see, this is one connection where there are horizontal loops coming from the wall elements in the vertical joints, and this is a plan, please note. And then we are putting a a rod inside, and the inside space is grouted with non-shrink grout. If the space is large, then we can have an inserted column. That means you're having reinforcement inside, and then you're pouring concrete. This is a connection of the slabs to the supporting beams. Again, you can just have a look through them. This is from beam to column, that how they're putting some, again, inserts to check the loss of sitting. Column to column splicing. Okay. Now, there are different types depending upon the company. Okay. The connection materials. Now, this is what I was saying, that these are called looped wear ropes. And they come in boxes. In our country, we typically get them from China or companies like Pico. They are also sending to us. Now, these loops are placed inside along the vertical edge of a wall panel. Okay. They are flexible, that when the panel is being lowered down, they can bend. There is not much of obstruction. Once they are in place, then these loops are opened up. The loops from the two sides are overlapped, and then you place the rod inside. Apart from this, there can be headed studs, bolts, inserts, and as I said, bearing pads is also very important. Sometimes we tend to skip bearing pads. That is not good, because then you're having direct contact of concrete to concrete. Okay. The production, handling, and erection of precast systems. Now, the production process, as I said, that unless you visit a factory, you don't understand what is meant by this industrial production of precast members. In this photograph, you can see that these are the wall members with the plastic ducts inserted, through which, when the wall members are placed vertically, the dowel bars will go through these plastic ducts. There can be different types of molds for the column, beams, walls, slabs, stairs. Each component has their own type of mold. Coming to the pre-stressing, again, you need to understand the way the pre-stressing operates. It means in the industry, you tend to be specialized of whatever you're doing, and understanding the losses, immediate losses, long-term losses. These are all necessary if you are introducing precast. You can have the hollow core slabs and even beams, piles. In terms of the way the factory is laid out, the carousel line, which is like an assembly line which is used in a car manufacturing, the similar type of thing has come in the precast industry. And this is the factory I saw, and lot of automation. Okay, that means gone are the doors that people are carrying buckets of concrete and pouring. Okay. Now this this is not of course of a building, this is of a railway sleepers, but I was impressed by this factory in the Patil rail infrastructure in, there's a small typo here, okay, in Coimbatore. And here you can see that for the construction crew, they have kept this flow chart, okay, so that these procedures are followed step by step. The preparation of the mold, fixing of the inserts, and so on. Okay, I'm not going through this, but this I teach in my pre-stressed course, that these are the steps you have to follow when you are trying to produce this type of members. Curing, demolding. This is from, of course, a bridge site. This is the undertaken by the Airport Authority of India Limited for the Chennai runway extension project. Here you can see that they went for steam curing, and then this is being demolded. You can understand there are handling stresses, and then they are subsequently, after steam curing for 24 hours, which is considered to be equivalent to 7 days of curing, then again you are doing moist curing. Transportation, handling, and erection. Now these are like construction equipment related. I am not the person to speak about this. This is a topic by itself. Okay. See, these type of topics I would strongly suggest to the educators, please introduce in your undergraduate level. The complaint is, once they go to the industry, they will say that these teachers had taught what they knew, but they did not teach what we need. Now this is a common problem. So we as teachers have a responsibility at least to introduce, so that once they go to the industry, they can pick up quicker. What type of trailers are being used? What type of cranes are being used? Okay, this is the photographs we took in our Sri City project. How are the precast elements lifted? Okay, these photographs I have taken from the handbook. Coming to quality control and assurance. Now, already there are certain codes in our country. The first one is, of course, under revision. Professor Pillai is chairing that committee. IS 15916, which is building design and erection using prefabricated concrete. The second one, IS 15917, this is related with the mixed or the composite construction. And there is an overall guidelines, which is the ISO 9001. Now, the purpose of awareness of these codes is that sometimes our engineers are not aware that these codes exist or the revisions are coming out. Now, that is dangerous. Okay, that means at least in the handbook we have highlighted that these exist and you should follow this. Now, the quality control under this industrialized process comes under different stages. First, the quality of the materials. For that itself, each of these materials have their own set of tests. Next is the quality on the processes. Okay, that how whenever you are manufacturing them, what are the quality checks? Again, I am skipping reading the details. Qualities on the finished product. Once you have made the products, some of them are tested. Sampling, some sampling is done. What type of tests are to be adopted? And then if there are repairs, if there is some damage, then again what type of test to be done? Do you want to demolish that or can you repair it? Now, these are the type of tests typically which is done in the industry. In this hollow core slabs, they will be placing some weights and try to see that at least they may not go to the ultimate limit state. Up to a certain amount of deflection, they will check that whether the stiffness is appropriate or not. On the contrary, for the railway sleepers, this is mandate from the Indian Railways that they have to be checked at least for the serviceability as well as the ultimate state and also the fatigue loading. In our lab, we have the fatigue testing facility where we do get sleepers from not only from the Indian Railways but from the neighboring countries to get it certified. Okay, the fatigue testing is another very interesting, and when you come to the structures lab, at least I will be showing the how we are doing the fatigue testing. Okay, by this what type of jacks we are using. Coming to the contracts and taxation. Now, in this chapter of the handbook, first the different types of contracts are mentioned. Which one is suitable for the precast? These are referred: the item rate contract, lump sum contract, cost plus contract, target value design, integrated project delivery. See, I am not the person to answer this, but in case if you want to know more about it, definitely you can write to Professor Raghavan, who was in the industry dealing with all these types of contracts. Now, the problem in the precast construction being popular in our country is that there is some excise duty because it is considered to be an industrial product. And once you have this excise duty, that inhibits the precast manufacturers, because again that's the profit margin is reduced. Now, how to tackle that situation? That's more of an administrative purpose, that in order to promote precast, that this type of excise duties should be reduced. Okay. Now, whenever you write a contract for a project utilizing precast construction, it is not that you just copy paste from whatever happens in cast in place. No, there are certain subtleties which are mentioned in this chapter that I will again skip reading, that the conditions of the contract, special technical specifications are necessary for this precast construction, and the taxation aspect also should be mentioned. Okay. Information technology in precast concrete. Now, the building information modeling is a tool by which you can visualize a project a priori. Larsen & Toubro has a huge facility where you have a walk-through type of facility. Okay, and this are very much suited for precast construction because it gives you a check of all the clashes that can come because of the different disciplines. We are talking of integrating the heating, ventilation, and air conditioning. Okay, the sprinkler systems. All this thing comes in a building these days. Collaborative and integrated project management is possible through this BIM, starting from tendering, constructability assessment, detailing, progress visualizations. We have our Professor Ashwin Mahalingam, who not only helps uh, the state departments, but also in other parts of the nation, where he is promoting the use of the BIM, especially for the uh, metro projects. He has been helping them. Okay, and this also leads to reduce of wastage, which leads to lean construction. Now, there are softwares like Revit, which can be used for precast construction. It also helps in change management. That means if an architect wants some change, that can be seamlessly integrated in this type of coordination. Last comes the case studies, and these case studies are primarily related with the frame type of buildings, where we are having moment resisting frames with precast beams and columns, and the floors are made up of hollow core slabs. That means we cannot cover all types of case studies, only 2 types were covered here. Now this is a project for the Infosys, and here you can see the extensive use of columns with corbels, beams, and hollow core slabs. Okay, and this is the finished building. I have scanned this from the handbook, that's why they are not very clear. Now these are the elements which are used in that building. Emulative connection, you can see the beam elements, the column elements, the hollow core slab elements. The other one is a parking garage in Chennai. Now here also you can see different types of elements are there, and again it's a framed construction, not wall type. Now to close, this handbook is a source of compiled information, okay, but this is not everything. Obviously that each one of you, if you are dealing with certain aspect, you have to go beyond. Okay, there are explanatory notes and illustrations, okay, and there are list of references. The Indian Concrete Institute is Chennai based, and you can purchase this book. I would say, see, especially I'm saying for the educators, that please have a copy in your shelf, so that at least you can tell the students that this is there. Because in our country what happens is people say we don't know. If I move from here to Delhi, they will say, oh, what you are doing in Chennai we don't know. That is very unfortunate. That awareness is not there of the documents that we have within our country. Forget abroad. Okay. That's why I strongly urge that please have a copy of this handbook, which gives you the overall idea about the precast. Okay, the price deliberately has been kept reasonable, so that even a student should not hesitate to buy it. Typically, whenever there is an ICI convention, there will be a booth of the Indian Concrete Institute. They will be selling this, and apart from this, there are other documents also. Our department produced the document on the industrial floors, which is also a very nice document. Okay, and there's some durability monographs are there. Don't hesitate to purchase this, and so that this is beneficial for your teaching.